Exponential that you know. Okay, what was the first one? Never touches x-axis. Okay, our second thing is that it is curved. So our third thing is it crosses the y where? At the y-intercept. The fourth thing is y equals a times b to the x power. Now, x is independent. And while we're here, so nobody gets to say another really easy one, y is dependent. Okay, number 6, it's a function. Why is it a function? Why is it a function? X's are all passes. Vertical line test. It is a function. Are all of these functions? No. They are. Okay, because your graph is going to look like this. What's this right here? Y-intercept. Or it's going to look like this. Okay, so for my growth, it's either growth or decay. He said positive or negative, but we're going to call it growth or decay. Okay, for growth or decay, number 8. A is the y-intercept. Another one is it goes on forever. In both directions. Unless we're doing a project, right? For growth, I'm going to say this a little bit differently than how they said it. When you're talking about growth, it's y equals a times b to the x. The b has to be greater than 1. Write it down. B has to be greater than 1. Okay, number 11. It's not linear. It's also not quadratic. If you're talking about decay, the b, she said has to be less than 1, but I'm going to add one little thing. It has to be between 0 and 1, not including the 1. Between 0 and 1. Okay, so 13, the b value tells you if it's growth or decay. Yeah. The b tells you growth or decay. Okay, so our last one is it's not direct variation. Because it does not cross through 0, 0. Okay, what's a line parent function? Linear is y equals x. Okay, how about quadratic? Is y equal x squared? Sure. Exponential. Y equals a times b to the x. Now there's growth and decay, right? They look different. All right, and then there's one more. I don't know if y'all remember this. We did this right before we did EOC, and it's the one that's xy equals a number k. Starts with an I. It has a V. Inverse variation. Inverse variation. It can also be y equals k divided by x. Okay, I'm going to give you an example, and you have to tell me which one it is. Inverse variation. Okay, so I'm going to pick a problem, and you have to tell me what it is. Okay, you ready? So how about y equals 5 times 2 to the x? Growth or decay? Exponential growth. Okay, now if I take this and change this and this to a plus and an x, what is that? That's linear. If I put a 2 right here, quadratic. Okay, I'm trying to kind of play with some things here. What happens if I change that to a times sign? Having to think. So this is just y equals 10x, which is linear. Okay, now what happens if I do this? Is this quadratic? Is this exponential? It's definitely not exponential because the x is on the ground. This is linear. Because this is really 2x plus 25. So does the square mean that it has to be quadratic? Any square in the whole problem mean it's quadratic? No. Okay, how about this one? Inverse variation. Okay, how about that's exponential. Now what if I take the height of that 2 and just take the x and put it here? That's linear. And if I put a square on the 5? Still linear. And if I put a square on the x? Okay, so here's my question. What determines which parent function it is? The x. Is it the position of the x? Wherever the x is, see? Wherever the x is depends on where it is. But here's the thing. If it has a square, does that mean it is quadratic? No. What has to be squared? The x. If there is an exponent, does that mean it's exponential? No. What has to be the exponent? Okay, so write this down. If the x is the exponent, it's exponential. If the x is the exponent, it's exponential. All right. Okay, one last one. What about y equals 12 times 1/2 x? That's linear. What if I take the x off? Nope, that x will have to be on the bottom. It's not inverse variation. It's not exponential because the x, there's not even an x at all.
No solution? All real numbers?
What is it? I heard somebody just say it. What is? It's not a point. It's a line. What is it?
It's a line.
Linear. This is linear. It's a line. It would be the line y equals 6, which is straight across at 6. Okay, now, what if I put a 2 right here? Now what is it? Nope. Not linear anymore. Well, sorry, it is linear. You're right. That would be linear. Now what happens if I put an x? Exponential. Now let's remember how to graph these exponentials because you're going to have this tomorrow on your test. where would I start this graph? The y-intercept, which is 12, because this is A. A determines the y-intercept. So I would go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I would go over 1, and I would take the 12 and change it to a 6, because half of 12 is 6. Okay, now my 2, I would take half of 6, which is 3. And now for 3, I would take half of 3, which is 1.5. And then I would have to take 0.75, and do you see what the graph is going to do? All right, that is exponential decay. In just a minute, you're going to have to make one of those by yourself. For the domain, it's all of your numbers that are listed right here, right? So on your my domain would be my x values, right? Do you have little squigglies around it? Mine stopped after the 10th M&M, so I would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, no, this is the domain of your table. These are not all real numbers. Now, my range is going to start with what? Whatever your last M&M was before you didn't have any left. My 8, 9, and 10 were all 1, 1, 1. So do I write 1, 1, 1? No, just write it one time. The time before that, I had 4 M&Ms. The time before that, I had 9. And so on and so on. Now, you need to fill all these out. Do not do this right here. You're going to fill this all in with numbers. And the very last number should be what number? Your y-intercept. Good job. Mine was 72. So you should have all those filled in. Now, that's the domain of the actual experiment that we did. Yeah. Now, can you do the domain and the range of your function that you graphed? My domain started at 0, and my domain ended at 10. Don't copy me. Make sure you write down what yours says. Mine went from 0 to 10. My range, what is my lowest number on my range? It would be 1. Now, is everybody else's 1? No, maybe. Some people, like your last one was 4 before you flipped, before it was all 0. Okay, and my highest was my starting number, which is 72. I don't know what yours was. Okay, so you want to make sure that these are labeled not with X and Y. Over here, you should have a title. Do you have a title? You should have what your Y represents. You should also have what your X represents. All that will be counted off if you don't have it all. Okay, the last thing you have to do with no homework. For no homework, the last place, you're putting this on the front, at the bottom, on the blank space. You have to draw 3 graphs. I lied. 4 graphs. Your first graph is linear. Make up your own linear graph. It cannot be the parent function. It's going to be an mx plus b form. Okay, the b is your y-intercept. It tells you where to start. And then the m is your slope, so you're going to do rise over run until you get your line on there. My second graph is going to be quadratic. And just to hurry you just slightly, let's all do the same one just so we can hurry. It's going to be y equals, what is it I need to start with? X squared. Let's do minus 9, just so we can do a quick one. So draw your graph. Where am I going to start? Negative 9. And do you remember, since there's no B, that is the vertex. Where is it going to cross the x-axis? Come on, thinking. Okay, if you solved this, it would give me x squared equals 9, which is positive and negative 3. So go to 1, 2, 3, 1, 2, 3. And there's my graph. I just wanted to give you a quick and easy one. All right, the third one is going to be exponential growth. So it has to be in the form y equals something times something to the x. Now you decide where your graph is going to start. That number goes first. You decide how quickly that number is going to increase. Is it going to double, triple, quadruple? You decide. Okay, so you're going to draw your graph. It's probably going to be a positive. You decide where it's going to start. Whatever number you're starting with, I'm just going to throw a 3 on here. For 1, I'm going to do 3. If I double 3, I would get 6. Okay, double 6, you would get 12. Move over 1 and then double 6, which would be 12, which is going to be way up here. And that's enough points for me. Does that make sense? Okay, so you've picked a number. A little bit bigger number's a little bit better. I liked his 12. And I'm going to do 1/3. Because I don't think a lot of y'all are going to do 1/3. Uh-oh. Is that our bell? Yeah. Yep. So for this problem, I would start at 12. And then I need to do, for 1, I would do 1/3 of 12, which is 4. Then I would do 1/3 of 4, which is 1 1/3. And then I would do 1/3 of that, and you keep doing 1/3, and your graph is going to come down, and it's going to be a decay. All right, that's what we did in class on Monday. We are having our individual test questions on Tuesday and Wednesday. Don't lose this piece of paper, but I drew another one for you in case you need to review it. Have a great evening. Bye.